Okay, well today what we're going to do is we're going to talk about solving proportions. Okay, and for the Indiana academic standards, for this time we're not going to have any standards for today. Okay, but our first vocab is proportion, and that's an equation that states that two ratios are equal. So in the last lesson we were talking about ratios being comparison of two numbers. Okay, well now we're going to be comparing two ratios. Okay, so an essential for your understanding here, if two ratios are equal and you have an unknown value within the ratio, you can solve for the unknown through proportions. So we're going to be able to do a little solving for an unknown value in this. Okay, so the first problem we have here is 5/6 equals x over 11. So what we have is just this problem here, and so what we're going to do is we're going to be able to solve this proportion. This is kind of like fractions, making sure they're equal. But how we can solve this is we can do a multiplication across from bottom to top that looks like that. So if we go this side here, we take 11 times 5 and we get 55. Well, if I can draw a 5 there. Okay, so we're going to take 11 times 5 and we get 55, and that's still equal in between. But 6 times x, we get 6x. Okay, so we get 6x there. Now we want to solve for x. We're right back to that one-step equations that we did in 2-1, which means we're going to divide by 6 to solve for x. Okay, when we solve for x, that makes 1 because these are going to cancel. Okay, and then as we cross multiplied here, 6 is going to go into 55 9 times with 1 over 6. Now you can leave it as a fraction to do your check, or you can write it like this. I would advise that we go 55 over 6 and do a fraction over a fraction. Okay, but that's kind of the long way to do this. There's actually a shortcut, and I'll kind of show you the shortcut here real quick. Now let me put that in green. Okay, if we say 5 over 6 is equal to x over 11. Now this is only going to work if we have this value that we're looking for right there. Okay, that's the only time it's going to work. Okay, because we want that value to be in the top. If it's in the denominator, we're going to have to cross multiply. Okay, but since it's in the numerator here, what we can do is we can just do what we've been doing in solving equations, and that is to multiply both sides by 11. And when you do that, you get 55 over 6, and then these 11s are going to cancel, giving you just x. And so you'll notice that these two lines right here are the same. Okay, so it's exactly the same thing. It's just that we do it quicker with one step. Now the reason why I showed you the other way is because a lot of problems you're going to have to cross multiply. So cross multiplying is the way you want to go, but sometimes if you pick up on the shortcuts, it just makes it simpler for you to work through. Okay, so we look at this, and what we did was cross products. I haven't really named that yet. I might have said it once or twice in there, but I didn't name it yet. Cross products is when you just multiply the diagonal. So like we did on that last problem, was we wrote 5 over 6 is equal to x over 11, and we cross multiplied across the equal sign. Okay, that's what we were talking about, cross products. Okay, now it only works across the equal sign. So we have the definition here. If A over B is equal to C over D, then what we can do is just cross multiply. Okay, now one thing we want to note and make sure that we know here is that we have to state that B cannot equal 0 and D cannot equal 0. That's the old rule, that we cannot have these values in the denominator as 0, because that would be undefined. But if we do this, as we go over to this side, we get AD equals BC. Okay, and they should be equivalent. So we look at this problem here, which says, what is the solution of the proportion 4/3 equals 8 over x? Okay, well the same thing occurs, but 4/3 equals 8 over x. We're going to do the cross products. Okay, so we're going to multiply across this way. Okay, and I'll ask this question, could we do this by just a multiplication to both sides? Well, not really, because again we have this x in the denominator now. So we can't just multiply by one quantity. We're actually going to have to do the cross products. Okay, so as we look at this problem, we get 4 times x, that's this right here, and then we have 3 times 8. Okay, 3 times 8, we get the 24. Now we want to solve for x. Now this is back in the 2, 1. So we're going to divide by 4 to both sides. Okay, divide by 4 to both sides. Those cancel. And we get x equals 24 over 4, which is 6. Okay, and again, I'd like to see you do the check, which would be 4/3 is equal to 8 over 6. Now we could check this by simplifying. 8 and 6 have a 2 in common, so 2 goes into 6 3 times, 2 goes into 8 4 times. You'll notice 4/3 equals 4/3, or we would actually cross products and see that they are the same. 4 times 6, just cross product here, 6 times 4 here, you're going to get 24. 3 times 8 this way would produce a 24 as well. So there's actually 2 methods to that check. Okay, so as we look at example 3 here, what we get is the solution of the proportion x minus 2 over 3 equals x plus 3 over 5. So right away we notice that we have a really difficult problem, but if you really think about it, it's not that difficult. It's the same steps. Okay, so as I write this problem out, the only thing that really changes is that we have to remember that in PEMDAS this is a grouping symbol, okay, the fraction bar. So what we're going to do is we're going to just illustrate the grouping right up top here. Okay, so we know that it's grouping, but the same thing applies. We're going to take this and we're going to cross multiply it using the cross products. Now when I do this on the left side, I'm going to get 5 times the quantity x minus 2. On the right side I'm going to get 3 times the quantity x plus 3. Okay, and what do you think is going to have to happen? Well, we're going to have to distribute. So again, as we talked about earlier, distribute property has not gone away. So 5 times x, we get 5x. Awesome. Okay, 5 times negative 2, we get negative 10. That's equal to, well, we got to distribute on the other side. Okay. So 3 times x, we get 3x. 3 times 3, we get plus 9. So now you're looking at this and saying, alright, well, we had variables on both sides. We cleared the grouping symbols. Step 2, we need to simplify by adding like terms. Well, on the left side, there's no like terms. On the right side, there's no like terms as well. So step 2 is really done. So we're at step 3 of that 5-step process that we learned earlier in sections, which is to get variables to one side. And again, we think ahead. We say, well, I want to subtract 3x because that'll keep me in the positives with the x's. 3x minus 3x cancels, leaving me with 9. On this side, I have 5 x's. I take away 3. I'm left with 2 x's. And then I still have the minus 10. Well, I'm going to add 10 to both sides because I want to get the constants to one side. Okay, and I get that to make 0, leaving me with 2x equals 19. Well, go up here so I have a little more room. Oops, change that. That's equals 19. I'm going to divide by 2, so I'm back to 2, 1 again. I get x equals, and I say 19 divided by 2, and I think about what that is. I get 9 and 1/2. Okay, or 9.5 if you want to write it as 9.5. Now again, you would check your work by plugging into the original problem up here. So what I want to go ahead and do the check off the side, and I'll be looking for that when I check your notes. Okay, make sure that works. Okay. So we get example 4 now. Example 4 is talking about ski socks. Okay, so there's some ski socks that are on sale at $3 for $40, or 3 pairs for $40. Sorry about that. Okay, we really want to know how much that is per one pair. Okay, so we're going to be using kind of the scale model. When we work with models, we really want to know how far is it per 1 inch, things like that. So we're going to be kind of working with that idea. So what we're going to say is that, well, we know that it's 3 pairs for $40. We want to know how much for 1 pair. And there's really a couple ways you could do this. Since we want to know price per 1 pair, I might say 40 over 3. Okay, so I'm saying this is my price per pair, but I want to know how much that's going to be. So I'm going to put cost. I'll put cost for how much 1 pair is going to cost. Okay, but I want to know for 1 pair. So that's how it would work. Now what you need to remember is that it's dollars cost up top and how many pairs on bottom. Those need to be the same. Okay, we don't want to put numbers of pairs up here and then the cost down here, because then that would not be across the same. So proportions have to be the same across. So we're going to do the cross product. So as we do the cross product, we get 40 times 1, which is 40, 3 times C, which is 3C. We're going to divide by 3 from 2.1 section, and we get 40 divided by 3, which gives me $13.33. So it's going to cost me $13.33 per 1 pair. If you're unsure about that, really just add that up 3 times. It should come out to be $40 with, give or take a cent there because we're rounding. Okay, but that's not the only way you have to do that problem. Some people might say, well, it's 3 first, so let's put 3 over 40. And then that equals, since pairs are on top, we have to put 1 pair on top. How much would that cost? If you pay attention to how this works, you'll notice there's some similarities. When we do the cross product, I still get 3C equals 40 times 1 is 40. And you'll notice that these are really the same equations. They're just the C's are on the left side this time instead of the right. So there are the ways you can do that, as long as you have pairs together on top, costs together on the bottom. Okay, make sure you understand that. Okay, so we're going to stop there. If you have any questions, make sure you let me know, and ask questions in class if you do, and we'll do some homework in class. All right, see ya.